Okay, so in this video, we're going to be talking about margin of error. So it says a study was conducted that analyzed scalp hair samples from 22 participants with epilepsy and 23 participants without epilepsy, checking for differences in level of copper, iron, zinc, magnesium, and calcium. So the results are summarized in the table below. So we've got males with epilepsy, males with non-epilepsy, females with epilepsy, females without epilepsy. And we've got their copper, iron, zinc, magnesium, and calcium levels. Now it says if it were possible to measure the presence of copper in the hair of all males with epilepsy in the world, do you think the average would be exactly 14 micrograms per gram? And explain your thinking. So, do we think right here on this table it says males with epilepsy, they have copper is 14. Do we think that if we measured every single male's hair with epilepsy in the world, would it be exactly a 14 average? And the answer is no. It probably will not match 14 exactly, but it will be kind of close. So we can just say no. It would be close to the study average. But probably not exact. So now it says, the journal article that contains the results of the study actually reports that males with epilepsy have an average of 14 plus or minus 9 micrograms per gram of copper in their scalp hair. What do you think the 14 plus or minus 9 means in this situation? So since it's plus or minus 9, that just means that it is 14, either 9 more or less, or somewhere in between 14 micrograms. So we can say the average ranges from 14 plus 9, which is 23, to 14 minus 9, which is 5. So males with epilepsy can range from 5 to 23 micrograms per gram. And so the plus or minus 9 is what's called the margin of error. This wording, however, does not mean that someone messed up the research. It simply means that no sampling method can guarantee that the sample exactly matches the population, but that the sampling techniques, when used correctly, can be trusted to give results that are accurate within a certain range. So since males with epilepsy in the sample showed an average of 14 micrograms per gram, the researchers are fairly confident that the true average of copper concentration for all males with epilepsy is somewhere between 5 and 23. Now it says, have you ever seen a news report that mentions margin of error, and what was the report about? So just some examples of reports with margin of error. We can say yes, there are some. Some examples would be political polls, measurements, hourly wage of specific careers, sometimes you might see them talk about CEOs on TV or on websites where it says this CEO makes this many million and this CEO makes this many million. And so you might see a range of hourly wages per one. They don't necessarily make an hourly wage, but if they were to break it up into hourly wages. Another example might be science experiments, and so on, so etc. Now, as an example, politician Paul and candidate Carl are running for governor, and the election is next week. The latest poll shows that politician Paul has 46% of the vote, while candidate Carl has 43%. The news report, however, states that this poll contains a 3% margin of error. So, What does this mean for politician Paul? Well, he has 46% of the votes, plus or minus our margin of error, which is 3%. So he has somewhere between 43 and 49% of the votes. Meanwhile, candidate Carl, they have 43% of the votes, plus or minus our margin of error, which is 3. So they have somewhere between 40 and 46%. And it's asking us, what do these poll results tell you about the upcoming election? Because these two ranges are so close to each other, we can't really tell who's in the lead. And they overlap. You'll see that politician Paul has a little bit of the same range as candidate Carl. And because of that, they're just way too close. Now, if it was candidate Carl only had 20% and politician Paul had 80%, it would be a clear values that we could see a difference between. But we can just say they are too close to decide. Now it says a study was conducted that tested the effect of replacing rabbit's soybean diet with Glyceridius sepium leaf meal, or GLM. The rabbits were randomly assigned to receive either 0, 5, 10, 15, or 20% GLM. The resulting effect on weight gain is summarized in the table below. And so we've got a table showing 0% all the way up to 20%, and then their weight in grams with a margin of error next to each one. So weight, margin of error, weight, margin of error, all the way down. And question 7 says, fill in the interval of the true mean weight gain for each treatment. Based on the results alone, what do you recommend to the farmers in the area and why? So we're just trying to find the range for the true mean weight gain. And all we want to do is we just want to take our average weight and plus or minus our margin of error to each one. So the 0% ranged from 958 minus 40 to 958 plus 40. So if you do the calculations, we'll have somewhere between 918 and 998 grams. For 5%, it was 887 minus 59 and 887 plus 59. And that would be somewhere between 828 to 946 grams. Next one was 992 minus 24 to 992 plus 24. So we're going to have a range of 968 to 1016. Uh, 15% section had 972 minus 33 to 972 plus 33 for a range of 939 to 1005. And then the last one, 20% section had 919 minus 44 to 919 plus 44 for a range of 875 to 963 grams.